Okay, we want to now try and distinguish between taxonomic groups, which are monophyletic, polyphyletic, or paraphyletic. Now, taxonomists are scientists that generally work with classifying, naming and classifying living organisms. Systematists are ones that like to examine the evolutionary relationship of these different groups of organisms. Now, it's the hope that the different taxonomic groups reflect evolutionary history. But generally, they're using morphological characters or whatever database that they have to generate these taxonomic groupings. For example, what species belong in taxonomic group green, or a taxonomic group that we might refer to as red, and a taxonomic group that we might be referred to as blue. So as currently classified, taxa B, C, and D are all in the green group. And this is an example from your textbook. And as currently classified, taxa E, F, and G are all in the red group, while A, H, I, and J are all in the blue group. But occasionally, we'll come across groups that don't reflect evolutionary history. And let's go ahead and take a look at what's referred to as a paraphyletic group first. Paraphyletic, okay? This would be a grouping that has a recent common ancestor, and most, not all, the descendants. And in order to examine this, we're going to look at the green taxonomic group. So we're talking about B, C, and D. So we look at B, C, and D, and we go back in time. Remember, these lineages reflect time. We're going to go back in time until those three lineages intersect right there at that node. That's their most recent common ancestor. Well, that most recent common ancestor is in the group, and most of the descendants are in that group. Most, not all. The problem is that A, based on this phylogeny, is more closely related to members of this group than they are to others, than to other members of the taxonomic group that it's currently in. Now, when this happens, it's not that big of a deal. It means the taxonomic group requires minor revision. And what we want to do is take A out of the blue group, and we're going to put it in the green group. And when we do that, we will have established a monophyletic group. So monophyletic it has that recent common ancestor and all the descendants. So now this clade, which is defined by this node, contains all the descendants, and all of those descendants will be in a taxonomic grouping together. They will be classified in the same taxonomic group. Okay, so if we take A out of blue, we put it over here in green, well, look what happens now with blue. The remaining blue taxa form a monophyletic group. So again, we go back in time. Here's the most recent common ancestor. And this is a nice clade, a nice monophyletic clade. So with minor revision, A, which apparently had been misclassified and not reflecting its evolutionary history, we've now established monophyly for the green group and monophyly for the blue group. What about this red group? That's the third kind of situation that you might have, and that's polyphyletic. Now, I don't have room to write that definition out, but again, what we're looking for is seeing whether or not they share a recent common ancestor. And there is no recent common ancestor that they share between them. That is what polyphyletic refers to. And when a taxonomic group is determined from a phylogeny to be polyphyletic, well, that's a little bit more problematic. It suggests that that particular group requires major revision. And we have a situation in the last 10 years or so where we've had prime examples of both the establishment or identification of a paraphyletic group and the establishment of a polyphyletic group that has changed our understanding or has changed the different taxonomic groups that we look at in the domain Eukarya. So let's take the example of this over here. If the green group represented reptiles, then A would have been the birds. So you're going to see when we talk about birds that they are actually now being classified as reptiles because they fall out as sister to this particular group. They are more closely related to members of that particular taxonomic group than they are to anybody else. All right, the other example in the domain Eukarya has to do with the fourth kingdom that has been generally recognized. So within the domain Eukarya, we have three well-established monophyletic phyla. Again, that's a high taxonomic ranking. We have the kingdom Plantae, we have the kingdom Fungi, and we have the kingdom Animalia. That fourth kingdom you may be familiar with or have heard of, Protista, is no longer considered a valid taxonomic group because it was determined it was polyphyletic. And that's when, in the case of the protists, we see that there's some more closely related to animals than anybody else, some more closely related to plants than anybody else, and some just very distantly related from one another. So this would be kind of the example here. So currently the domain Eukarya is under drastic revision. It's not going to impact our understanding of the classification within the kingdom Animalia, but it will change the number of kingdoms that are finally established within the domain Eukarya.